We are going to start this webcast officially. A couple of things that I need to know or need to say. The webcast will be recorded and will be accessible after the fact through your SANS registration account. You can access this webcast and any of the others that we've done along these topics. In addition, the slides that we will be using today, which are on the lower end, meaning there's not a high amount of them, but the slide content will be available as well, downloadable PDF through the same portal registration. And last, there's already some conversations and discussions occurring in the Zoom chat. Typically, if you have questions that you want us to answer, please put it in the Zoom Q&A option, and we will try to respond to those while others are speaking, and then possibly address them at the end before we close. If you're just trying to send us funny comments and make us laugh, then the chat is perfectly fine. We pay more attention during the webcast to the Q&A, certainly, to make sure we address any questions that come up. I think that is the official announcements that I have. Other than that, as we work through these slides and this presentation, there's going to be a lot of conversation and discussion as we go. There's some slides where I have a plan, and I'm going to talk about some things, and then Rob and Paul are going to divert me from that plan. But definitely, as questions come up, please answer or ask them as we go. And since we'll all sort of be talking along the way, we're just going to handle introductions right up front in the beginning. So first, my name is Tim Conway. I work for the SANS Institute in the Industrial Control System curriculum. I'm an instructor and author within the Industrial Control System curriculum, and come from U.S. critical infrastructure, electric utility, combined natural gas for a number of years before I joined SANS. Rob, you are next in the list for me, so if you would like to introduce yourself.
Hello. I'm Rob Lee. I'm a senior instructor and course author here at SANS. Wrote the ICS 515 and the Forensics 578 course. I'm also the CEO and co-founder over at Dragos. And my background was U.S. intelligence community and Air Force focused on industrial control system threats.
Great. Paul?
I had the honor of serving as Assistant Secretary of Defense for Homeland Defense for President Obama. And since that time, I've done everything I can to support Tim and Rob as they help strengthen critical infrastructure security, and especially in the industrial control system realm.
We appreciate everything you do.
Writes all the good stuff. We just comment on it. So Paul's being humble, of course.
Yes, of course. Okay, I'm going to get us moving. A couple of slides are just really to kind of cover some of the events that have occurred historically, some of the actions that we've taken within SANS to try to gather information, gather resources, and help in any way that we can. Amongst the three of us, we are all good friends. We've known each other for a number of years. We are generally pretty jovial, but this topic is not something that we're pretty jovial about. It's a very concerning topic for the globe, and all of us on this call have done work in region, have relationships with organizations and companies over there, and we take this very, very seriously. So right when things started to occur, we released kind of a week ago a general urgent webcast from SANS that brought together a couple of different resources, really trying to tie together the different communities that look to SANS for some level of guidance or information and knowledge. And that included Rob T. Lee, the other Rob Lee, included Kevin and Jake and myself, and each of us kind of covered a topic area. So whether it was system defenders or malware analysis, cyber threat intelligence, and we did a little bit on ICS. And across that broad webcast with tens of thousands of people there, I knew the majority of people that were joining may have never heard of industrial control systems, may not be familiar with cyber-physical systems. So we spent some time on some background of what those systems are and why they matter and how they differ from IT. We knew each one of those topic areas really needed to be kind of its own webcast dedicated, and that's what we've brought together here today. Really a focused discussion on critical infrastructure, operational technology, and industrial control systems. And for that group and that community that is has areas of concern there specifically. Other things that I would call out other than that webcast, if you have a need for more of hearing that broader discussion across kind of IT, OT, where they blend, definitely would refer you to that. And the Cyber Resource Center that's been stood up that is kind of collecting all of these resources across the community, from webcasts, live streams, papers on defensive techniques that asset owners and operators can pursue, Internet Storm Center daily posts that are relevant in regards to the escalation and activities that continue to occur, CISO action items, and security communications templates from Lance Spitzner, and kind of the way you're communicating to your employees across your organizations. So with that, one of the items that we covered, and I'm now looking at my other two panelists to sort of, in the webcast that we had last week, I talked through some of the events that have happened in the past and how those events have sort of focused on impacting and targeting confidence of citizens, the world, kind of in the ability to provide essential services and necessary kind of life-saving capabilities, as well as, you know, the things you count on every day, from power to water to natural gas. And looking at some of those things, kind of targeting the confidence level, the attacks that occurred in 2007 in Estonia, the election kind of manipulation and influence operations that have been occurring, as well as kind of a lot, kind of broad brush over the years in Ukraine against kind of services and government provided systems that their citizens and general public rely on a daily basis, continuing to attack and deteriorate those from an availability, from a functionality perspective, and really just targeting the confidence in people with their own government to sort of provide that that service and in a safe way consistently. As you move past that into targeting capabilities, so looking at SolarWinds and that ability to target that security service and that security product in ways where it could be used as an access path to get to and achieve other things. Looking at things like VPN filter attacks and turning your perimeter firewall devices into pivot points to get into environments. Looking at NotPetya and kind of targeting the trusted relationships that exist across businesses, and doing all of that targeting in a way to ensure access and certain capabilities that an adversary may want to call upon. And ultimately, some of those may be in this other column of targeting and gaining control. And across kind of the lessons learned of these attacks that have happened from Georgia to Crimea in 2014, some of these include cyber and physical. Some of them include just pure cyber. And as you look across all of these things, looking at critical infrastructure and these targeted systems, you can kind of learn from how did these attacks, were they constructed, the concept of operations and delivered in the past, and what can we anticipate not only for Ukraine, but for other countries and other critical infrastructure abroad. Before I leave the slide, I'm just curious if there's any comment from Rob or Paul on the collection there.
No, I'll state that obviously I think it's appropriate, and I would make sure we stay guided as practitioners on what we know can happen. Oftentimes in these scenarios, the things that I think drive the most, the largest lack of confidence and the most churn in our organizations is we start trying to prepare for the unknown unknowns, but people haven't focused on the knowns. It's folks that want to talk about firmware security and zero trust and a water authority, but haven't removed TeamViewer from an HMI. So we got to be really focused on what are the things that have actually happened, ground truth reality. That's why we look to Intel and kind of the past. And oftentimes what we find is by making sure we cover those scenarios, we end up providing protection against scenarios we haven't accounted for yet either. Correct. Yeah, this case study approach and case studies that inform and influence exercises and practice, probably one of the most valuable learning opportunities. Otherwise, we're in a model where we have lessons observed, meaning something happens and historically we acknowledge that it happened, but we're not changing or modifying our preparation or defense to prepare for what it might look like when it happens again, and certainly how it could expand from how it happened before. All right, we'll move on. An item as we started kind of differentiating in the past from kind of IT data attacks, data at rest, data manipulation, encryption, and into OT or cyber-physical attacks, and what that might look like on a targeted facility, and even worse, kind of attacks at scale across a footprint.
and sort of looking at what that might be from a disruption to an operation impacting attack, causing outages or service delivery capabilities, to equipment overwrites and technical elements that would modify what you could do from a restoration or a recovery effort, and ultimately really, really trying to drive home that across all critical infrastructure, the dedicated people that are going in every day, we have spent so much of our lives in our careers in learning the importance of reliability and keeping the system up. But as we begin to lose integrity of some of these systems and adversaries are operating within those environments with us, then it really becomes do we have the necessary visibility and understanding of what they're doing so we can make that important decision of, do we want to continue to make a system 100% reliable if someone else is in control of it and they could drive it to a destructive component or misuse it to impact other targets? That really changes the mentality of asset owners and operators for many people their entire career that are looked at and focusing on reducing outages and ensuring reliability. But now if someone else is in the system and you're still trying to maintain it and keep it 100% up and available for someone to misuse, it's a different way of thinking that needs to be considered. Any comments on that before I move on? Those were the only 2 slides I really wanted to cover from the last webcast in case people did not join us for that. And I know that's going to inform some of our conversations as we move forward. Any other comments, gentlemen? All right. Now, some things that I knew I didn't have time to cover in the last one, but they were all well underway. They've been underway for over 6 years. And it's when you're looking at this from the perspective of critical infrastructure, and I think of some of the courseware that Rob has written in ICS 515 and 578, where you're really understanding kind of the state of the world and what's leading into some of these events. There has been an ongoing effort from a number of countries to sort of desynchronize from the Russian and Belarusian electric system and more into the European and the NETSO-E energy markets, and kind of contributing and participating in that electrical system in Europe. Specifically from within Ukraine, going back in time as they were filing for those considerations and looking at the technical and engineering elements. That's when we started to see some of the events of 2014, some of the events of 2015. And if you are the larger energy market looking at bringing in a new entrant who's going to be part of that system, certainly reliability is something you are looking at quite a bit. And if that country is being attacked, you have an understanding of those risks that you'd be bringing into your system that would flow in. Over the years, from the 2014 attacks to the 2015 attacks, we've been getting closer and closer and closer to Ukraine desynchronizing from the Belarus and the Russian system. And some tests were performed on February 16th with an actual plan to fully desynchronize for the first time ever in the February 24th through the February 25th timeframe. As everyone on this call knows, attacks occurred starting along those same lines, which allowed for a disconnect from Russia and disconnect from Belarus, but not a connect to the European energy market. So effectively operating as an island. So since the beginning, kind of these are the posts from the Ukrenergo. That is the state transmission system operator. They have been operating independent from Russia and Belarus. And 4 hours before the attack started is when they severed. So you look at the timing of that and you look at the targeting of this critical infrastructure. If they had connected into the NETSO-E energy markets and then you attacked a transmission system, the impacts of that electric system attack don't stop at borders. That flows into other countries, and those other countries being NATO supporting countries, that changes the dynamics from an adversary perspective or from an attacker in regards to how this may spill over and bleed into other areas. It also changes the dynamics of while they're attacked or while they're connected, it could certainly spill back into your own nation. So there is a unique window here to do things within the electric system and critical infrastructure precisely when they did, meaning disconnected from Belarus, disconnected from Russia, but not yet connected into the NETSO-E. So some important things there in regards to implications. And kind of the post to the right here is the continuing and ongoing request for stable power for human health and services to allow a connection into the Unetso energy markets from Ukrenergo. Another thing that you could read into this and sort of see is, and a lot of people won't think it, you should understand that you're seeing these requests and you're seeing this activity, which means there's still operators and control centers in country. There's still people in nuclear facilities still operating the generation assets and the thermal and the hydro and all the critical infrastructure that matters. There are people sitting at desks knowing that they're sitting in a target. Just keep in mind kind of the dedication of the operators that are in these facilities trying to continue to support their nation, their country, and thoughts and prayers with every single one of them. A lot of us on this call have worked with those folks overseas, and I know how hard it is to run an electric system normally, but in a state like this with shelling occurring and a lot of other things happening in country, it's really unimaginable. Right before we've sort of finalized this presentation, some events occurred at the Zaporizhia nuclear facility, which is the largest in the southern region within Ukraine. Certainly, again, this implications in regards to unavailability. The largest generation source in a interconnection will definitely begin to create problems of stability and balancing throughout the country, and will certainly create some critical infrastructure, electric system cascades or faults that can become a reality. So again, considering the connection into other energy systems and the risks that they would be taking on, definitely implications that need to be understood, and understanding who is now operating this nuclear facility, as well as another one to the north of this that is currently sort of being attacked and targeted as well. The last two slides that I have, and actually before I go beyond those, Paul or Rob, do you have any comments sort of on the implications and where critical infrastructure and industrial control systems kind of in a joint cyber physical attack like this really kind of the importance of highlighting what the state of the system is and understanding it before you can sort of develop a concept or an attack against it?
I'll actually take a different angle, and I'll leave that one to Paul if he wants to comment. One of the things that I've said in my classes over the years, and I think we all as defenders need to be mindful of, is we get to control pretty much everything on the defensive side. Get to define the architecture, define the layout, define the skills, define the plans, define the mode of operation, define the security tools. We get everything. And so in many ways, it always leads me to say that defense is doable, and actually defense has the upper hand in many ways. The one thing you don't get to decide is if the adversary thinks you're a good target or not. And I do get the sense in conversations I have with a lot of people outside of Ukraine of well, they wouldn't attack me, or why would this hit me? And again, you don't control that, but I'll use just this slide as an example of targeting a nuclear power plant is a war crime under any discussion. It is also insane under any discussion. And so I just hope that as we go forward, without causing fear and hype, we also have to be mindful that our adversaries do not always operate inside the same bounds of reality that we do. They're not irrational, but they don't rationalize things in the way that we do. And I think this one slide is a pretty good reminder for us in ICS security on the types of work that we do, and making sure that we're prepared for lunatics.
I agree with that. And I'd add, initial safe shutdown of a nuclear reactor is only the first step. We're not out of the woods, because maintaining emergency power, the resupply of diesel fuel for generators until such time as the nuclear plants can be restarted as part of the transmission network, that is some potentially difficult footwork to execute, even if you own and operate the nuclear power plant, much less if you're an invading army with no intimate knowledge of the facilities you've just taken over.
Yep, I would say, and I've said this a number of times, but when we're going to a conference or we're delivering a presentation or we go to meet with a team to talk through kind of an assessment or work with them as a support aid, oftentimes someone will say, well, we've brought subject matter experts, and or this is person X who's a subject matter expert. And in industrial control system space, there's so many of us that is not a title we ever like to hear associated with the introduction of us, because we know every facility we go into is unique and different, and we get to put the learning hat on, which we love, and say, tell me about how you operate this facility. What systems, what protocol, what vintage, what digitalization, how are you operating this mechanical physical system? How have you chose to do that? And it's unique everywhere you go. And that is certainly the case within a complex environment like a nuclear facility. And if you had one operator retire and another one come in, you would have spent years cross-training and preparing and certifying, on-the-job training, validating that individual. Now you have potential people sitting in operating areas that are completely unfamiliar with this complex environment. There's definitely some consideration there. To Paul's point, don't just think of a nuclear facility as the thing that it's generating and the megawatts that it's pushing. It itself has a load of essential service and auxiliary power to maintain kind of overall plant processing and really important reactor cooling water, pumps, cooling ponds. And if those essential services or auxiliary power is unstable, or the balance of plant capability has been impacted, this becomes something to really, really pay attention to within a defined timeline of hours. So definitely something to keep your eye on. This piece was something that I really wanted to kind of focus on as in one statement on a IT side, and kind of to the right, kind of the global view of, hey, if we are running a business in this part of the world, do we need to really, really kind of focus on what's happening in Ukraine? And there's a lot of discussions there, certainly to the comment of what Rob was stating, that you don't control adversary intent, you don't control the geopolitical environment, you control your system capabilities and kind of your defensive approach. So definitely do the things that you can control, but the types of things that might be seen from a cyber perspective and the positioning and effects-based targeting that you might see globally would differ greatly from what you would see in Ukraine, where cyber and physical are a coordinated element of this invasion and attack, with physical being the obvious greatest component and easiest to deliver consistently at certain targets. If that is an element of an attack, it's certainly what you would see in Ukraine and potentially in bordering countries. But for those nations who are coming to the support of Ukraine, for those nations that are viewed as negative to the adversary country, there is certainly a lot of things that could be presented from a cyber perspective in the traditional IT domains, as well as the critical infrastructure OT domains. And Paul, I really wanted to ask if you had any additional kind of comments on this slide before I move to the next. You're muted. Sorry. I keep going back to you guys instead of you being muted. Go ahead.
I'd say move on, because I've got some additional comments when my slide comes up. Thanks.
Okay, perfect. Here we go. The last one that I have before I'm going to turn this over to Paul is something that Rob has seen in courseware, kind of across these attacker objectives, and some slides and PDFs and white papers that we put together over the years in regards to thinking about adversary objectives. And as you look back the many, many years ago when this was created, and we were looking at sort of a loss of view or a loss of control component, so creating a situational awareness issue for operators or for instrumentation and control people in the field that are looking at a process, and the impacts that could have on them and why that would be targeted, and moving into more of a denial of view or a denial of control. And ultimately, as we sort of talked about manipulation of view and we got down into manipulation of safety, those were things that were being considered and being talked about. But as the years went on and we started to see actual developed capabilities being used in the wild, manipulating safety instrumented systems and specific kind of targeting along those lines, this moved from a conceptual thought of how this could occur into it's happening in the wild, and specifically from DOJ kind of and Treasury Department announcements, some of these capabilities, everything on this list, there's been some effort naming this adversary using every one of these elements from an attacker objective historically over time. From a defender perspective and looking across what we normally do from a reliability perspective, we would normally build a industrial control system, operational technology, or process environment with full redundancies, full fault tolerance, multiple views, multiple points of access for operators. So kind of a small scale loss of view. We have well-defined plans for that loss of view, loss of control at a small scale for a short period of time, meaning equipment has failed or has been misconfigured or something has happened. When it's a targeted achievement and it's happening at scale, that's truly where a number of environments and a number of facilities haven't really thought through what that looks like, going to full control inhibit, going to full manual operations, and sort of performing tasks without their control systems and without visibility, meaning taking other points of data and trying to understand what the state of the process must be in based on data points and telemetry. Looking at denial, that adds a little bit of a different time, meaning everything may look normal to an operator until they go to call upon a service. And that's when they identify that they've been denied that service, denied that function, denied that capability. So now you have all the same problems as the loss of, but now you're adding in a time function of not only can you not have it, but now is when you need it. And last, this is the piece kind of on the manipulation side. And this is really where all the work we've done over decades and working with asset owners and operators and countries around the globe, this is an area where we have not prepared well, meaning the system is up, the system is available, everything is working, but somebody else is controlling it. And what actions do you take and what have you architected into your environment to enable you to operate through the attack, to enable you to continue your mission while your system's been impacted? Rob, the next slide will be for Paul. Do you have anything you would like to say on this one before I exit it? All right. So Mr. Paul Stockton, I have put a couple of different topics on this slide, but really, I think it is fair game for you to talk about whatever you would like on this topic. And we will all be listening attentively. I'm certain Rob and I will have some discussion and some comments as you move along. So Paul, I'll turn it over to you.
I'd like to start by borrowing from Sherlock Holmes. Fellas, we have a dog that did not bark in the night here. It's very peculiar from my perspective that we haven't seen large-scale, sophisticated cyber attacks in conjunction with the physical attacks that have been underway. And I think that's especially odd given Russian military doctrine. The fellow who is commanding this operation for the Russian military, General Valery Gerasimov, he is the founder of New Generation Warfare. And a key component of New Generation Warfare, as it's been described by Russian military documents, is to employ devastating cyber attacks early in a conflict to disrupt the adversary's command and control and potentially critical infrastructure essential to the functioning of the victim nation. And we have not seen that. And it's even more strange, Tim, because as you pointed out earlier, Russia has already used Ukrainian power grid as a laboratory for testing out, for example, the use of misoperation of critical grid components. My guess, and I'd be interested in your thoughts and those of everybody participating, why we've only seen very limited DDoS cyber attacks, for example. I think Putin believes he can win without taking on the escalatory risks that large-scale cyber operations would entail. And he said this morning, you may have seen it in the paper, quote, Putin, we have absolutely no intentions with regard to our neighbors, Putin said. There is no need to escalate the situation. I think everybody should think about normalizing relations and cooperating normally. He believes he's going to conquer Ukraine with his existing kinetic operations without having to resort to cyber attacks, without having to reveal the capabilities that Russia has been assiduously developing since the attacks on Ukraine's power grid. But I also believe it's way too soon for Putin to declare victory in Ukraine, and way too soon for us to let down our guard. Let me offer a few thoughts now on critical infrastructure preparedness and options for resilience and incident response, turning to that second topic. First of all, if cyber attacks begin on a large scale, stop downloading software updates from the cloud, right? There's certain no-brainer things that infrastructure owners and operators need to do in the ICS realm. And there's other measures that I think we should have ready to roll out if the current events in Ukraine begin to spill over into cyber operations against the United States. But I'd like to focus on the longer term. First of all, it's foolish to assume that cyber attacks against US industrial control systems will be one and done. If you believe that, you're smoking the strong stuff. Anytime that China or Russia gets engaged in cyber conflict on large scale against the United States, it'll be part of a campaign to seize control of the Baltics or Taiwan. And as long as that campaign is going on until either they win or we do, we can expect sustained attacks on industrial control systems, multiple weeks, as we've planned for in the GridX exercises. And during that campaign, we have to assume, and everybody on this call needs to assume, that the adversary is going to seek to monitor and disrupt the restoration of operations and restoration of ICS functionality. Tim, as you pointed out, they're going to be trying to be inside our systems, exploiting persistent access. And that, I want to emphasize, not only applies to the initial attacks, but efforts to restore functionality. It's going to be utterly unlike dealing with hurricanes or other natural incidents. They're going to be inside our restoration efforts. And above all, I'd suggest, and Rob, you've been doing a lot of work in this realm, as we anticipate what the grid of the future is going to look like, with fancy power electronics to make up for the loss, for example, of inertia and spinning reserves. There's all kinds of cool things we have going forward in the grid. I'd say the same of water systems and other infrastructure systems, where ICS provides the tools for modernization, and ICT connected ICS is key to much of that future. Every time we move down that path, we could be opening up new attack surfaces. So geez, let's figure that out now before we build out the grid of the future, the water systems of the future, and build resilience into the 2B system rather than trying to patch it after it's built, which is much more difficult and expensive. Thanks, Tim.
Yeah, and
I almost started talking unmuted. Rob, go ahead.
Yeah, I'll hate to just parrot everything Paul said, but I want to add a couple things based on what I heard. So I definitely think a lot of us are shocked to not see cyber operations employed in Russia. However, a couple things come to mind. The first of which is it appears, and we won't know for a while, but it appears there's just a real overconfidence in the Russian military and what they were expecting to find, to the degree that we see a lot of the young soldiers maybe drank too much of the Kool-Aid and misinformation, thinking that the Ukrainians are just going to throw down their arms and welcome them as liberators. I think part of the problem with the narrative for Russia on the narrative that Putin had to sell to his own people is that his own people bought it. And I think they prepared differently as a result. The other thing that comes to mind, you talk about the spillover effect, is they have experience with that. NotPetya, as an example, massive spillover effect, much more than they could have possibly realized, leading to numerous countries in the world attributing it to them and coming out pretty strongly on the topic. When we look at even the 2016 attack in Ukraine with the crash override malware, turns out that malware could work on almost every transmission site in the world. So I think they've had some reinforcement that some of the capabilities they want to use and leverage do have a significant effect elsewhere. And as you're trying to contain something and not be escalatory, I think you're spot on, Paul, of that has had to have factored into the calculus somewhere. Also, the defense community for all the things that I always hear on Twitter and elsewhere, the cybersecurity community has actually done a lot better. The state of cybersecurity today versus where it was 15 years ago is very, very different. And defenders adapt much faster than we used to. Not saying everything's perfect, but much faster. And leveraging some of those capabilities you may need later is absolutely a way to get them burned quickly. And when you're thinking about going into traditional and conventional warfare in Ukraine, maybe you don't feel for the overconfidence or otherwise that you need those cyber capabilities. But if you're going to have an asymmetrical kind of conflict with other larger military forces, you better have those type of tools in your toolkit. So yeah, plenty of things to explore there. But on the softball that you threw to me at the end about kind of the digital transformation and kind of the changes that we're making in the systems, I think the without hopefully causing any fights, and Tim, you can feel free to jump in as you want in the statement, but I very much love our infrastructure community and the fact that we've always focused on developing safe and reliable infrastructure. And as a result, that has lended towards a natural level of security. As that transformation takes place and as our threats become more focused on industrial control systems, though, that's going away quickly. And the reality, in my opinion, is our infrastructure is becoming less resilient naturally over time, regardless. The nature of industrial automation, the complexity of it, the difficulty to get root cause analysis, common operating systems, where an attack on one plant used to be very, very different than another, but now it's getting a little bit more cookie cutter. The reality of interconnected industrial environments through vendor accesses and OEMs and similar, like it's just to a place that even when you don't consider the cybersecurity of it, our electric system, our water systems, et cetera, are becoming less resilient. And I think that's a debatable point. But as far as I see it, especially Paul mentioned the inertia problem and kind of the beauty of renewable energy resources. While they have lots of promise, they change the makeup of our electric system. And we look at the role of market managers and ISOs and generation authorities not having really understanding of the transmission side of the house and so forth and so on. It just has a lot of seams for things to go wrong in between there. And instead of just highlighting a lot of issues in my section, I'll talk about some of the things we can do about it. But I think what I'll end that comment on is the thing that we have to do is pick a path. And it seems like no matter what path we pick, you'll have a large portion of the community not in favor of whatever that path is. We tend to be a little bit resistant to change. We have our own inertia on the system. And I look to what the Biden administration did with the ICS National Security Memorandum and the 100-day action plans last year with the electric sector. And there was plenty of antibodies that came out on, I can't believe we're doing this. And some, are you implying that we're not secure? And, I want this technology, not that technology, and all sorts of trash. And at the end of the day, a lot of the community members in the electric community got it done. And as the Ukrainian conflict started to kick off, and I looked at where we were in under a year difference, again, I don't really care what answer we picked. We picked an answer, and we were better off for it. And so I think the reality is we have a lot of desire sometimes to have inaction based on the fact that it's not the perfect plan. And in these scenarios, we really just need to push forward on some choices and then figure out the impacts after the fact. But just letting things stay status quo, we are already naturally deteriorating in our resilience capability, and we got to fix that. No, that's very positive. We're joking at the beginning of the webinar. They're like, "Here's where we're screwed," but we're gonna come back on it. Folks, hanging on. Here's some actual things we can do as a result. But anyways, that's my thoughts on kind of what Paul was talking about there. But Tim, over to you.
Piece that I think is a question that Paul addressed that comes up often is, and it spreads out into a bunch of different tentacles and kind of the spectrum of what you're asking is. Oftentimes the question will be, so why hasn't there been more cyber physical components of this invasion? And certainly any country in the world that understands that is Ukraine. They've been, as they're adding digital capabilities, as they're automating processes in the field, those things from 2014 and beyond, every year there's a knock on the door where they're being manipulated and being impacted. So as this continued to escalate and escalate and escalate, there's reasons they're disconnecting from a way of operating that has been there from the existence of electricity in their region. There's reasons they're changing. And you could assume that they would have been moving towards manual controls and trying to do things in more manual control inhibit ways, the way you would if you were going out and buying a new SCADA system and putting it in the field. You wouldn't immediately trust that that system was accurate and all the tags and all the display mappings were right. You would control inhibit, field point verify. The same way you would bring that system on. Now, if you know there's a potential for a targeted cyber attack to manipulate your critical infrastructure, you would move to that operating model without question at scale. And over the years from 2014 and beyond, as you added those capabilities and you saw them targeted and misused against you, you would have reluctance to continue to add and adopt more. So we would get questions from different journalists, have they invested in their cybersecurity capabilities? Have they invested in kind of their overall control capabilities so that they could rapidly restore? And it's, if you have one use case of your adversary is a storm, meaning a storm comes through and causes a bunch of power outages and then moves on, you would have a use case to say, we want more distribution automation. We want more SCADA control. We want to reduce the duration of an outage. We want to reduce the frequency of an outage. We want to put in all kinds of automated controls in the field so we're not driving a truck out to every site to do restoration. If the storm isn't your adversary, but now it's a nation coming in intentionally misusing, the more automation and more digital controls and more targets you're adding, the more problems you're going to create. So certainly within some countries, you could kind of look at it to the perspective of automation has so many necessary economic and operational benefits that it's going to continue to explode. But there's certain defense critical sites where maybe that's not the smartest move. And if you're a country like Ukraine, maybe your large bulk power systems, that's not the smartest move for a period of time until there's some stability. Meaning if they were in the NetSOE energy markets and tied to that system, that changes the dynamics from an adversary nation coming and manipulating their system, as that will impact other countries. So the timing of when to invest and how to invest becomes very, very strategic at a national level, not just a company business level of we're going to go do these energy efficiency programs and invest and pursue smart metering and microgrids. And it's a different world from a planning perspective, and they have different considerations to take into account for sure. Certainly within US and other countries, there are certain sites that we should be looking at in similar ways.
And let me carry that analysis a step further, and that is the electricity subsector and some other components of US infrastructure have made significant progress, which I support, in developing supplemental operating systems, spare tires, if you will, for skinny down SCADA and OT operations of their networks in ways that aren't as robust and capable as normal SCADA operations, but still give you some fallback functionality. Carrying your line of analysis a little bit further, there's still a risk, even in these fallback SOS systems, of misoperation, intentional misoperation, and that risk needs to be countered as we build out fallback SCADA systems, just as we anticipate the increasing mechanization and automation of infrastructure as a whole.
The time for growing and merging operations, engineering, industrial control system professionals, cybersecurity professionals, and people who can think from a misuse case perspective, the time for getting those people in rooms and organizations and in governments and across governments is absolutely now. To understand how what we have can be misused and manipulated to damage, and what we're going to go build as targets. What can we do now to make them more resilient? With the 15 minutes we have left, I'm going to move us to Mr. Robert M. Lee. We have one slide after this that we'll kind of cover, and it's really a lead into an effort that Rob and I are hopefully going to be working on soon. But for now, Rob, I'm going to turn this over to you.
I like how you teased what we're going to do, but didn't reveal what we're going to do.
I know. I'm
new exciting things coming.
I'm leaving that to you.
Look, there's plenty of questions, and so I'll take my section short, especially since I've been talking. Anyways, what I'd like folks to know is, I think there's extremes in the community at times. Oh my God, we're all going to die. Didn't you see there was a phishing email on the power grid? To there are no such thing as ICS attacks. This is all stupid. And it's kind of right in the middle, right? There's not one grid, and you can't take it down like that. And if you think there are no ICS attacks, it's because no one's talking to you about them, but there are plenty of them. Uh, and I'll kind of keep it in the middle, would say, with what's going on in the Ukrainian conflict, if we talk about prioritizing, which is what this webinar is about, there are plenty of companies who should not be focused on what's going on in Ukraine right now. And I across the 16 critical infrastructure sectors the DHS tracks, I think that there's a lot of them that it's just not a focus right now. Plenty of other things to be doing, but there are plenty that you need to be paying attention. As an example, when we look at ransomware, the ransomware operators over the past couple of years have had an extraordinarily sort of strong bench strength of people that now understand what it is to target the industrial side of infrastructure companies. And there have been plenty of ransomware families that have had ICS processes and things embedded into them. But more importantly, they just know, hit that side of the house, whatever that is, hit that side of the house, the person pays faster and pays more. That's a strong signal to criminals. And there have, when we look at all the ransomware attacks last year, and we just published our year in review reports over at my firm, we look at that, I think around 70% of them or so were in manufacturing. Just based on the current hygiene status and targeting focus in manufacturing, about 70% of all the ransomware attacks were in manufacturing. And of all of them, like 60% of them were just two groups, Lockbit 2.0 and Conti. And it was Lockbit and Conti that came out when all this started and said, we're siding with Russia. If anybody comes and does anything against Russia, including sanctions, we will attack you. So you look at that and you go, manufacturing tends to be the largest one. And the two largest groups have both come out and made some pretty big signals that they intentionally want to go after infrastructure. So number one in my book is, if you are in the manufacturing industry, broadly defined, chemical manufacturing, food manufacturing, if you're in the manufacturing side of the house, I would be making sure you are extraordinarily well prepared for ransomware on the operations side of the house. There's some preventative things you can do. There's some detective things you must do, but you must have an ICS specific incident response plan for the operations side of the house as a result of ransomware with that scenario. Underneath that, we tend to see a pretty big tit for tat aspect out of Russian government based teams. In other words, if 2014 in Crimea, when they invaded Ukraine and took Crimea, Western financial institutions sanctioned Russia. So there was attacks against Western financial institutions. JP Morgan and a number of other banks get compromised and heavily impacted. The same thing, we are seeing sanctions again, but now we're seeing discussions today. President Biden is talking about sanctioning Russian oil and imports. So the next thing down to me is, if you're in the energy sector, electric, which we always know to be a big focus anyways, but especially oil and gas, and especially liquid natural gas, that is my next rung of you better be paying attention. And as we look across the past year, the different threats and the groups that we track targeting industrial organizations, last year, we, in October, started identifying Exenotime, which was the group that tried to kill people in Saudi Arabia with the Trisis attack. The US government came out and attributed it to the Russian government. That group started becoming active again. For a long time, they weren't active. We started tracking that group again, being active, and they started doing reconnaissance, not compromising yet, but reconnaissance of key electric and liquid natural gas sites around the United States. We shared that to our customers, to the government. I think that led to some of the conversations that have been happening around potential blowback of cyber attacks. But it is very clear that they are picking out the targets. That is not to say they're compromised anybody yet. But if you're talking about the ability to do a cyber attack, it's not a light speed thing. It is months of planning, if not longer. And so for manufacturing and broadly energy, those are the two that I'd be paying a lot of attention. And I'd be looking at crash override style attacks. I'd be looking at Trisis style of attacks. I already see questions coming in. I'm like, hey, do you have indicators of compromise? It's wrong question. So I'm not trying to put your question down, but wrong question. Don't worry about the indicators of compromise. What you should be worried about is the tactics, techniques, and procedures. If it's a Schneider system in that one facility, the indicators might be focused on this form of Trisis. But if you don't have a Schneider safety system, and also it's just going to be configured differently anyways, that malware is not going to be the thing that you see. but you're going to see adversaries that have the capability and the knowledge to know how to get on an engineer workstation, use native functionality and control protocols to be able to modify logic on a running safety system to cause an unsafe event. So you're looking for those behaviors. Don't focus on the indicators of it. This is also where some of the folks in the government were like, oh, you saw scanning of utilities. I'm like, yes. What utilities were getting scanned? I'm like, that's not the point. We can talk to them. That's fine. But yeah, but what's the IP address of the scanning? It doesn't matter. What are you going to go to a utility and say, hey, you're getting scanned? And they're going to go, great. What do you want me to do about it? Well, we don't know. That's not useful. There are things that do and don't work in cybersecurity. Knowing where the targeting might be can be useful. Over focusing on what's the IP address, not useful in the type of conflict we're talking about. And so it is incredibly important, again, to focus on those behaviors. Now, here's the critical thing that I'll share with you, and hopefully this will get us to the next slide as well. If you have not been paying attention, if you have not been doing security efforts before 2015 or between 2015 attack and all the stuff that Tim, Paul, and I have been talking about, I'm not trying to be harsh here, but we're talking about real war, so I'd like to be candid. If you've not been paying attention from 2015 up until the end of 2021, there is nothing you're going to do for this crisis with ICS security projects and initiatives like, hey, let's go shields up. If you didn't prepare to do that, you can't do it now. So the honest answer is prepare for the next crisis. And on this one, dust off your incident response plan and make sure you've got talented folks that know your industrial side of the house that can prepare and respond with you. And if you want to do anything short term, it's things like tabletop exercises. You can roll out an IT security project in a couple months. You're not doing it across your key sites in an ICS network. It's not a 6-month IT project. So a lot of the discussions of let's go shields up and all that, while I appreciate the discussion out in the public community, for those of you in the asset owner and operator community, you should be going hunting and preparing to respond, not, hey, how do we keep them out? That boat's gone. All right. So like, if you haven't been paying attention, please don't waste your efforts on this crisis. Focus on the next one. So if we can go to the next slide. In my opinion, and honestly, just based on all the data and the analysis we have and all the different attacks we have, there are 5 things that you can be doing that matter a whole heck of a lot. I saw some of the questions already in the chat on, hey, if I'm from IT security, how can I be useful on an OT? Welcome aboard. First of all, you can be extraordinarily useful. We need all the help we can get. But the most important thing you can do is focus on what is the mission at that site? What are they trying to accomplish? Not what your security biases are. Don't come in and go, oh, Windows 7, it's vulnerable. I don't care. I could sit you down on the terminal and ask you to make the lights blink and you couldn't figure it out. That's not the point. The vulnerability in the exploit, stop that. What I care about is understanding what the mission of that site is, looking at the system of systems and figuring out what could go wrong, not only based on the consequence, but based on a threat-based view. And let's approach it that way. Then you map over your security controls and mindsets. And so without running out the clock here, I'll say number 1 to me is defensible infrastructure. What is the point of a defensible infrastructure? What's the definition of it? It's something that you can add humans into to make it a defended infrastructure. There is no such thing as secure products. There is no such thing as defended infrastructure on tools, but you can have a defensible infrastructure that I can drop humans into it to make it defended, which means if you got a flat network with unmanaged network switches, your incident's going to suck. Okay. So make sure that you actually have a defensible architecture, whether it's firewalls and SDNs or whatever. It's a place that I have an understanding of what's in my environment. I can get logs and data and I can drop humans into it to actually do the defense. Incident response, like I said, ICS specific incident response, tabletop exercise between IT and OT, who's the actual owners and operators of what we're doing, what skill sets do we expect to have, et cetera, what questions are we going to need to answer, not only for operations, but legal, regulatory, financial, et cetera. Let's make sure we know those ahead of time so we have the right data configured in that defensible infrastructure to support the incident response. Number 3 is a classic IT security control, but this one applies very well. The ways you might deploy it are a little bit different in operations, but if you have remote access, which all of you do, unless you're operating a nuclear power plant, you do. If you have remote access, put MFA everywhere where possible. If you can't, then depend on your defensible infrastructure and do compensating controls. Number 4 being operational visibility. To me, that's that ICS network monitoring. Choose your vendor of choice. As long as they can understand ICS protocols and communications and see the commands going back and forth and so forth, it is a big leg up. It's not only good for root cause analysis and troubleshooting non-cyber events, but in this case, remember, this isn't system and data security. I don't really care about your EDR and I don't care about encryption of data. What I care about is system of system interactions. I need to see how system 1 interacts with system 2 to cause a physical manifestation in system 3. And number 5, on process management, you've got a lot of understanding of that operational environment and embedded in your operators and engineers' heads. And you really need to figure out what is normal, what is the change management process, how do we understand what a baseline of good conditions are. I'm not saying baseline every protocol and network and everything else in your environment, but talking about the crown jewels, the things that are actually important to your environment. Would you know if somebody was making a logic update outside of a maintenance cycle? And if that's not appropriate to your environment, you need to be aware of that and looking for it. Tim, I'll throw it over to you since you made the pretty slide.
Yep, I made the pretty slide. So this slide has a history in that going back many, many years ago, Mike Sante and myself were talking with a vendor who had sponsored a webcast, and they had this question of, hey, have you guys thought about how the CIS or the SANS 20 critical controls apply to OT and ICS environments? And we sort of went through the 20 that were there, and Mike and I kind of prioritized, here's 5 things, or I think it might have been 6 things at the time, that we would prioritize as higher priority within an OT environment. We built a couple of slides, had a webcast on it. And since then, Mike, myself, Rob, we've been talking about not just pulling from the 20 that exist, but really looking at what are the 5 that matter. And Rob and I have kind of been talking recently about what those things would look like. And as we had discussions, there was this underlying foundation of, even if practitioners are pushing for this, even if they're trying to get budgets, even if they're trying to get it baked into projects and trying to do it from the start or do it in existing systems, there needs to be this foundation of support from leadership, from management, from the business owners and operators that say, we will run programs that achieve these things. And that's kind of this bottom layer of understanding how you're going to go do a defensible infrastructure control. You're going to need to start with this thing on the left of where are our networks, where are our environments, where are our assets, and how are they prioritized based on our business need, the service that we provide in the community, health, safety, kind of knowing yourself and moving across left to right, looking at kind of understanding what the risks and threats are to your mission and how those apply to your systems. You're not going to achieve anything that's on this slide without staffing and organization and trained individuals with the tools and technology they need to go perform their job. Looking at all of those kind of plans and how they operate with or interoperate with your essential service. So meaning your operating environment, meaning there's all kinds of connections you have across a defensible infrastructure because there's a business and data hunger for the operational data from your plants or from field environments. But in an escalated attack, you can deprioritize those things quickly if you know about them and you have controls in place that you can sort of manipulate what's allowed and why it's necessary. Again, getting down to the core elements, kind of the spare tire system that Paul had mentioned, what is absolutely essential? What telemetry from the field or from the plant floor is absolutely required in order for you to run the mechanical process? And that's it. Having that understanding takes time, and then building these kind of 5 critical controls around it. The last piece is the vendor partnership side. No company stands alone in this world. So regardless of which critical infrastructure you're from or what process you're operating, you likely didn't build all the systems, didn't build all the applications, didn't design it all, and run into an operate and maintain cycle without vendors involved. And they absolutely need to understand your risks, your capabilities, how to support your mission best. And in a lot of cases, we rely on the vendor community for managed services for normal operations now. So just key components there. I'm going to get us off this slide so I can show contact information for everybody here. But I really do want to answer.
Paul, do you want to? Yeah, we don't.
Yeah, the Article 5 question I wanted to save for Paul.
Yeah, I just answered them all in Q&A, so they should be good. Paul, do you have any closing thoughts and remarks?
I'm good. I would say one issue for further analysis, gentlemen, is given the threat that you've described and the remediation measures, the resilience initiatives that are required, what constitutes now government support to ICS operators? What is actually of value as opposed to bullshit like IP addresses? What are the implications now for the terrific progress that President Biden and his team have made in government industry collaboration. What should we be looking to next, given your understanding of the risks of misoperation?
Well, for our next 2-hour panel, look, it's a beautiful question. I'll do my best to be short and say, number one, there are plenty of things that we do that are stupid and of no value. We need to call it that and move on. It's just wasting everyone's time. TSSD2 regulation, stupid, idiotic, move on. Like, just there's certain things that are just distracting. We don't have time for it. There are certain things that are working really well. When CISA and others get out there and amplify, hey, based on all the things and all the sources we're seeing, here's a couple things you should focus on, and here's the things that you should be doing. That gets board of directors' attentions, gets CEO attentions, gets president's attention. Like, they do a wonderful job in that type of amplification. But there's also things that we just have to accept as a society. Although I think CISA is doing a lot of good work, I also look at discussions in Congress around, we want more funding to go do assessments at water facilities. There's 55,000 water facilities out there. I don't care how much you think you're going to do, it's not happening. But as a society, we're not paying the true cost of maintenance and ownership and operation of our infrastructure. So when you look at your water bill, there's hidden societal costs, not even in just the cybersecurity, but also just the pure maintenance of the normal water system. And so there's just and reasonable rate increases that we have to pay, or we will continue to deal with this crap, and they'll just keep passing the buck thinking that some federal government agency needs to step in. Is it national security on defense critical energy infrastructure sites? Make the government pay for it. Is it just and reasonable on any type of risk today of general things? That should be a just and reasonable rate.
Awesome. Thank you both. We are on time. Rob has gone through all of the questions that were out there. I think we are good from a question perspective. Again, the slides and the recording will be available through the SANS portal. If you navigate to the webcast page, you can access this webcast plus previous slides will be available in a PDF in the coming days. I appreciate everybody attending. Appreciate both of Rob and Paul taking time out of their days when I know they really don't have time in their days right now. So greatly appreciated both of you. Thanks for joining. And with that, we will close the webcast. Thanks again.